Hello everyone, so welcome to the first lectures of the series Unit and Measurements. We are going to learn about the unit and measurements, in which we will cover the topics like the physical quantities. We'll understand about it, and then units, types of units. After that, we'll go to the dimensions, and we'll practice some questions that are important for our competitive exams. Okay, so our chapter is about the unit and measurement. So measurement is very important. So it plays very crucial in our life, because everywhere we see around us is all about measurements only, right? When we go to markets, we see that the shop owners, after measuring only, they give the things to us. Similarly, when we go for playing, when you see in the sports, the football grounds, the cricket pitch, all are measured, and there is measurement time also, right? There is duration of time, like football is played for 90 minutes, so there is also a measurement. So in physics, okay, in physics, anything that can be measured are called the physical quantities. Okay, physical quantities means anything that can be measured. So we know obviously what are the things that can be measured, right? Examples: we can measure length, yes, we can measure time, we can measure force also, etc. So there are many physical quantities that can be measured. Obviously, some of the feelings, okay, thinking, pain, this cannot be measured. Okay, so these are not the physical quantities. Okay, next, what we have now, see, there are lots of physical quantities and we have to measure them, so it will be very difficult for us, okay, if we don't provide some difference between them. Okay, so now, in order to make it easy for us, this physical quantity have been provided with certain, okay, with certain standard. Okay, with certain standard, this standard may come in the form of signs, symbols, letters, sentences, okay, in order to differentiate this physical quantity, and that standard is called the units. Okay, unit means it is the standard. Okay, it is the standard given to physical quantities, okay, for measurements. So unit means this is the standard, okay, given to the physical quantity. Now this standard come in the form of symbols. Okay, this standard come in the form of symbols. Somewhere we see sentences, okay, somewhere letter also, okay, etc. So the standard comes in the form of symbols, signs, like letters, etc. So now, okay, unit means it is a standard, right? Okay, let's see an example. If I have to measure the length, okay, if I have to measure the length, now this length, if I say 5 meter, now this meter is called the units. Okay, similarly, if I have to measure the weight, if I have to measure the weight, suppose someone is 25 kg, now this kg, this symbol is called the units. Okay, next, these units are of two types. Okay, these units are of two types. Okay, let's understand one by one slowly. These units are of two types. Okay, so it's in these units are of two types. One is fundamental, the other one is the derived. Okay, let's see what is this fundamental units. Okay, so fundamental units means the units that are assumed. Okay, the units that are assumed are called the fundamental. Assume means in the sense that, okay, if I say about 1 meters, okay, if I say about 1 meters, and in that 1 meters certain length have been assumed. We cannot ask why that certain length have been assumed in 1 meters. Okay, it have been assumed. Okay, it have been assumed to measure the other physical quantities. It have been assumed, okay, that 1 meter, that much length will be there. Okay, we cannot ask why, it is assumed. Okay, similarly in kg, in 1 kilogram certain mass is there. and that mass have been assumed. We cannot ask why that much mass is only there in 1 kilograms. Okay, it have been assumed. Okay, it have been assumed to measure other large quantities. Okay, so these types of units are called the fundamental units, where the units are assumed. Okay, that is called the fundamental units, and the units over here are independent from each others. Just now I said length and kilogram, kg. This length is totally different and kg is totally different. They are not dependent on each other. They are totally different from each others. Okay, so units over here are independent. Okay, units over here are assumed. Okay, and independent. Okay, units are independent and units are assumed here. Okay, so there are 7 fundamental quantities. Okay, so let's write it down. What are the 7 fundamental quantities? What are the 7 fundamental quantities that we have assumed it? Okay, so that assumed fundamental quantities are mass. Okay, whose SI unit is symbol is kilogram. Okay, next we have number 2, length. It's meter. Its symbol is meter m. Okay, and the next we have time. So time is SI unit is second and its symbol is second. Okay, I'm writing the symbols here. Okay, next we have the current. So it will be current is ampere. Okay, and its symbol is A. Next we have number 5, temperatures. SI unit is K, Kelvin, and its symbol is K. Number 6 we have luminous intensity. Now what does this luminous intensity say? So luminous intensity means when we have to measure the brightness of an object. At the times this is the quantity that is used. Okay, like if the sun is stars, stars. If we look in glare into the sky, and some of the stars are very bright, and some of the stars are a little less bright. Okay, so now to measure their brightness, this quantity is used. Okay, luminous intensity. Its SI unit is candela, and its symbol is CD, small letter CD. Okay, next we have amount of substances. This is also new. So amount of substances means, when I have to measure the large amount of substances. Okay, when I have to measure the large substances. Suppose in this my markers there are millions and millions of atoms. Now when I have to measure these atoms, when I have to measure such a huge number of atoms, that times this physical quantity are used. Okay, amount of substances. Its SI unit is mole. Okay, and its symbol is MOL. Okay, so these are the 7 fundamental units. Okay, that you should remember it. Okay, sometime it may come in the exams. Which of the following is not a fundamental units? So there may not be with this. Okay, there may be not this. So we have to remember all of this. Okay, so these are the 7 fundamental units. Now let's go to the derived units. So derived unit, the sentence itself says derived. The sentence itself is saying derived. So now the units over here are derived from the fundamental units. Okay, the units over here are derived from fundamental units. We'll understand with the help of examples. Okay, this one. Now here units are not independent. Units are not independent. Okay, so let's understand with the help of an examples. For examples, we'll take one examples of speeds formula we know. Yes, distance by time. Okay, so distance unit, we need unit only because we are finding the units only. So distance unit is meter and time unit is seconds. So you see here, okay, this is a derived units because its unit is made from the fundamental units. So these are both fundamental unit or not? see distance meter, okay, length meter, and then second, both are the fundamental units. So because of fundamental units only, this derived unit is met, right? And if we remove the s from here, okay, time from here, then will the derived unit comes? When the speed comes, when the speed of formula of speed comes? No, it will not come. So this both the units should be there. That means these units are dependent on each other. It is not independent, right? So this way units are not independent here. In any derived units are not independent. Okay, we cannot remove this, and then after that we will not get the derived units. Okay, so units are dependent on each others. Okay, so the units in which the units are dependent, they are called the derived units, and it is there from the fundamental units. Okay, so let's derive the units of other physical quantity. So this is example one. Now let's do for velocity. So velocity formula is what? Displacement by time. Now what is displacement? What is the unit of displacement? It is meter. Yes, and time is seconds. So meter per second. So this is the unit of velocity. Let's derive the unit of other physical quantity. Number 3, derive for acceleration. E is equal to velocity by time. So velocity is displacement by time, and then we have time. So it will be displacement by time, right? Displacement is in meter by second, and the time is again second. So how we will do this one? So see here, whenever there is, so s means, okay, s means s by 1, right? We can write like this. See here, whenever there is like a by x equal to b by y, okay. So now whenever this divide is multiplication, okay, when this division when we multiply, then reverse will take place. Okay, we will write like this: a by x. So now division is getting into multiplication. Then this will get reverse. Okay, y will get by y. There is b by y. Now when we multiply, it will get reverse. Okay, it will be y by b. It will be y by b. Okay, y is at up now. Y have become numerator and b have become denominators. Okay, so next what we can write here? So m by s into s by 1 is here. So we can inverse it. So it will be 1 by s. So what will get? Meter second square, or meter second square. So this is the for accelerations. Next we will find out for force. Force F is equal to mass into acceleration. So mass, the SI unit is kilogram, kg, and acceleration just now we got, so we can directly substitute it. Okay, not it will do long. So if you know, just substitute. Okay, meter second square. So it will be kg meter second square. This is the unit of force. Okay, next. Next we will find it out for work done. W is equal to force into displacement. We find it out for this one. Okay, number 6. Find it for kinetic energy. T is equal to half of mass into velocity squares. We find it out for this also. Next we find out for power. P is equal to work done by time. Next we find out for pressure. E is equal to cost per unit area. Yeah, those who know formula, very good. Okay, number 9, you find it for charge. Yes sir, what is charge? What is the formula of charge? I don't know. So charge formula, charge is I into T, where I is the current. Okay, I is current and T is time. Okay, I will do this for you. I current. So what is its SI unit? Its current SI unit is ampere. Time is second. So it will be ampere. Second is the unit of charge. Okay. So this you pause it and you do it, and then we'll go to the next, that is the dimensions, for which we have been waiting it. Okay. So let's see what is there in this dimensions. Okay. Okay, so before I go to dimensions, okay, we know what is power, right? In indices we have learned, if ax is there and by is there, then x is, okay, power of a. Similarly, y is power of b, right? This x and y are what? They are the power. Okay. So now dimension means, dimension is also one type of power only. Okay, but it is the power of the fundamental units. Okay, so dimension means it is the power. Okay, it is the power of fundamental units. Just now we learned about the 7 fundamental units, so you remember that. Okay, so dimension means it is the power of fundamental units. Okay, let's understand what is this power. Okay, what is the power of these fundamental units? Examples. Okay, density. You know density formula. Okay, let's write it here. Here we'll write. Okay, example 1. Density we know. What is the formula of density? It's mass by volume. So now mass, volume means length into breadth into height, right? So it will be all are length only. So it will be length cube. Array volume means length into breadth into height. This all are length only. Measure in length only, right? So length is, this length is length only. Breadth is also length only. Height is also one type of length only, right? So that's why it will be length into length is length cube. Okay. So now when it will go up, mass will have the power of 1, length will have the power of minus 3. Now this 1 and this minus 3 are called the dimensions. Okay, this mass is the fundamental units, length is the fundamental units, and their power is called the derived dimensions. Okay, so how we read this one? We read like this: the dimension of density in mass is 1 and in length it is minus 3. Okay, this 1 and minus 3 are the power of these fundamental units. Mass and length both are fundamental units, so their power is called the dimensions. Okay, now this sentence is very long now. Okay, it will be difficult for us. Now for our convenience, these fundamental units have been provided with certain symbols. Okay, this fundamental unit have been provided with certain symbols. Okay, let's write it down. What is this? Okay, symbols. So mass can be written as, this mass can be written as capital letter M. It should be written in the bracket. Okay, it's a system of writing. The mass can be written as capital letter M and it should be written in bracket. Okay, similarly, length can be written as capital letter L and it should be written in brackets. Similarly, time, okay, capital letter T, and then current is ampere. For temperature, it is Kelvin. Okay. Next, what we have? luminous intensity. So luminous intensity, a CD, okay. And then amount of substances we have a flask. You write it nicely. Amount of substances, it is a mole. Okay, this is the symbols given for the 7 fundamental units. So that means, okay, that means this mass can be written as capital letter M. Okay, instead of written in bracket, this is a system of writing. And length can be written as capital letter L, right? And its power is -3 and its power is 1. So dimensions can be written as like this. And one thing you should remember, it should be written in the form of MLT, okay? MLT. M should come first after the L and T, okay? And if another quantity come, then you can put it in the last, MLT. If temperature comes, if current comes, then MLT, okay? If another quantity comes, current comes, okay? If temperature comes, then you can put it like this, MLT, K, okay? But MLT should comes, okay? So now this dimension can be written like this. So now it should be in the form of MLT. So it is like this, M1 L to the power -3. Now T doesn't have any dimension, so T to the power 0. Okay, so this is the dimension of density, and this is how we write the dimensions. Okay, now don't assume that the T to the power 0 is not 0. Okay, T to the power 0 is equal to 1, and T to the power 1 is equal to T. This is simple maths. Okay, T to the power 0 is not 0. Okay, T to the power 0 is equal to 1, and T to the power 1 equal to T, right? Okay, let's find out the dimension of other physical quantity. Okay, so this one is of density. Now we'll find it out for velocity. Okay, this is my favorite, velocity. I like it, the word velocity. Okay, it sounds so fascinating. Okay, this let it be here only. Okay, number 1, velocity. So velocity is displacement by time. So displacement is meter only, length only, right? So it's a length only. So length only, and it is a time only, right? So length can be represented as capital letter M. It should be written in bracket time, capital letter T. So what will be this? T will go up. So L T to the power -1. Okay, here L to the power 1 you can write, or it's up to you, okay, whether you write or not. So now this is the dimension of the velocity, and it should be written in the form of MLT. So M dimension is not there, so L 0, L1, and T to the power -1. Next we will find out for acceleration. Okay, A is equal to velocity by time. The velocity, again velocity is displacement by time. Okay, and then within one more we have time. Next what we can write, displacement is length only, so directly capital letter L. So time is capital letter T. Next we have again time. Okay, so what can we do now? L by T. This T means T by 1, and 1 by 2 will get, okay, so it will be like this. So now L by T square. Okay, so now when this T will go up, it will be L to the power -2. So this is the dimension of accelerations. Okay, so you can write it in the form of MLT, M0 L T to the power -2. Here you can write 1, or you can, it's up to you, okay, whether you write 1 or both are correct. Now we will find out for force. What's the formula of force? Yes, force is mass into accelerations. Very good. Okay, those who knows, very good. So mass is kilogram. Mass can be written as capital letter M. And now estimation, just now we got m0 L1 t to the power minus 2. Okay, m0 L1 t to the power minus 2. m0 L1 and t to the power minus 2. Now this power will add up. Nothing will share 1. Okay, so m 1 plus 0 means it will remain same. L1 and t to the power minus 2. Okay, you can write it here 1. Now this force, dimension of force is very important. You rather you memorize it this one, because it's going to come again and again. Okay, you memorize it. The dimensions of force is m1, L1 and t to the power minus 2. Okay, next we have for work done. Work, W is equal to force into displacement. See, force came again now, so directly you can substitute m1 L1 t to the power minus 2. Displacement, what is the displacement? Displacement is length only, it will be m. So what you will get? It will be m1 L1 1 plus 1 2 and then t to the power minus 2. This is the dimension of work. Okay, next we have pressure. Pressure P is equal to force per unit area. So you find it out for this. Okay, everything now you will do by yourself. Okay, so pressure is force per unit area. Next you do it for kinetic energy. K is equal to half of mass into velocity square. Okay, number 7, find it out for linear momentum. This formula is P is equal to mass into velocity. Find it out for this. Next we have charge. Charge Q is equal to current into time. Yeah, this one I'm going to do it for you. Q is equal to current into time. What is the unit of current? It is ampere. Current can be written as like ampere. Okay, current AE. Time is T. So you can write it like this: A T. Okay, A1 T1. Okay, you can write it in the form of MLT, or you can leave it like this also. Okay, A to the power n, T to the power 1. Next, 8. Number 9, you have stress. This formula you will get it. Okay, and this formula you will get it in your when we will go on learning the further chapters. At the times all this formula will comes. Okay, this formula may be new for you all. Number 9, stress. Stress is force per unit area. Okay. Number 10, we have strain. Strain is change in length by original length. So what will be this? Change in length and original length, right? So both are length only. Okay, so both are length means both will cancel out, so that means it will be 1. So 1 means no dimensions, so no dimension means you can write it like this. Okay, but dimension is not there. Unit is not there means dimension is also not there. Okay, so m0 L0 and t to the power 0. Okay, a dimension mass is also not there, L is also not there, and time is also not there. Okay, next we have for sin theta. You find it out. Sin theta perpendicular by hypotenuse. Okay. So now both are length also, here also both are length, right? Perpendicular is also one type of length, hypotenuse is also one type of length, so this will be also dimensionless. Okay, These are the dimensionless quantity. Next, find it out for you find it out for reflective index. This formula we got it in our class 10 light chapters. If you have not got, you learn it now. Okay. So reflective index formula is velocity of light in vacuum by velocity of light in medium. So what you will get here? Say at once you can say it. Light in vacuum, velocity, the velocity. So both are velocity. That means they will cancel out. It will be one. One means without unit. It is without unit means it is dimensionless. So dimensionless is written like this. Okay. Yes. So you practice here all the questions that I gave you. After this, now we will go to the dimensions that are important for our JEE NEET preparations. Okay, but before going to this, whatever questions I gave you, you pause it and then you practice it. After that only you come here. Okay, we will go to the important JEE NEET questions. Okay, we will see what are the questions. Okay, all the formula that I will be giving here, you will learn it. Okay, don't need to worry about that. You will learn it in your higher class, or not higher classes, in the upcoming chapters. Okay, so it's like this, that all from this it will comes, not like that. You have to, whenever you get any new formula, okay, when you're learning the chapters, whenever you get any new formula, just simply you find out their dimensions. Okay, because any formula may comes in the exams, so their formulas dimensions you practice it once. Okay, it will not take even 2 minutes. So when you practice and practice and practice again and again, it will not take even 1 minute. Okay, so let's see important for JEE and NEET. Okay, so let's see what is that important for JEE and NEET. The first one is the universal gravitational constants. I think I have heard this word. Yeah, you have done it. Okay, you have heard it already. When there are two bodies, okay, when there are two bodies, they attract each other. Okay, when there are two planets, they attract each other with certain force. Okay, and if distance between them is r, then we will write this formula like this: F is equal to m1 m2 by r square, where m1 and m2 are the two planets, masses of two planets, r is the distance between them. Then there is one constant. That constant is called what? Universal gravitational constants. So now we have to find the dimension of this gravitational constants. Okay, so what will be this? G, we have to take it right side. Okay, and let it be right side, and all the other times we have to make it on the other side. Okay, so G F r square is equal to, it will be G m1 m2. So it will be m1 and m2 will come down. So G will be like this: F r square by m1 into m2. So m1 and m2 is there. m1 and m2 means both are masses. So capital M, then it will be m square. Right? We are going to do fast now because I told you to pause and practice that one. Okay? So we will do it fast now. Otherwise, it will consume time. So you can write m2. Okay? You can write it inside or outside. No problems. Okay? So now F, I told you to remember about the force. It's very important. It's going to come again and again. So it will be m1 L1 t to the power minus 2. This one is a force, and this one r. R is the distance between the two planets. So it will be length square. Okay. So what will be this? M will go up. So there are changes in m1. 2, it will be minus 2. L 1 plus 2, and then t to the power minus 2. So what we can write? M to the power minus 1, L to the power 3, and t to the power minus 2. So this is the dimension of the universal gravitational constants. Okay, you can copy it down. Next, we have for universal, okay, not universal, permittivity of free space. Sir, we haven't heard this one. Okay, you will hear this one, this permittivity words in your 12th. Okay, but the formula is similar to our universal gravitational constants. Okay, but here there will be charges now. Okay, two charges are there, so they will try to attract each other or they will try to repel each other. So there is certain force. Okay, and if the r is the distance between them, then that formula is given by F is equal to Q1 into Q2. The two charges are there. The distance between them is R squares. Now that just like this gravitational constants, you will get one constant, that is 1 by 4 pi epsilon naught. Okay, this E that looks like E is called the epsilon. Okay, epsilon, and this 0 means naught. Okay, epsilon naught. Now we have to find the dimension of this epsilon naughts. Okay, so now this one is the constant term. Okay, it doesn't have any units, so no unit means no dimension, so we are going to neglect that one. So now E naught will come this side. Naught is equal to Q. So two charges are there, we can directly write Q square. Okay, so it will be F R square, right? E have come here and F have come down. Okay, next, now Q is equal to IT. We have done already this one. Q is equal to IT means Q is equal to I into T, right? Current into time. Current is ampere and then this one is time. So Q square is there. That means we can write A square and T square. Okay. Now F, see, force is coming again and again. So it is better you remember it. Okay. You remember it, better you remember it. M will go up. -1, L 1 plus 2 minus 3, so minus 3, right? So T, when T will go up, then it will be plus T, 2 plus 2, 2 plus 2, okay, and then ampere will remain as it is. So what will be this? Yes, m to the power -1, L to the power -3, T to the power 4 and A to the power 2. This is the dimension of the permittivity of free space. Free space means what? The charge may be sometime in liquid, charge may be sometime in solids, or charge may be in present sometime in gases. Okay, free space here means there is nothing, only two charges are there. Okay, that's why it is called free space. You will learn it in 12th. Okay. Next, you find it out for, these are all importance for our NEET preparations. Okay. Next, we'll find it out for universal gas constants. Okay, universal gas constants. So universal gas constants means this in kinetic theory of cases. In the 11 itself you will get this one. So here you will get one formula, ideal gas equations, PV is equal to RT. Okay, where P is pressure, V is volume, and R is this universal UGC, universal gas constant, and T is temperature. Okay, so now we have to find the dimension of this universal gas constants. Okay, we have to find the dimension of this R. So what can we do? What can we do? We will keep this R on one side only, and this T will come down, so it will be PV by T is equal to R. Okay, or R is equal to PV by T. So now let's put the dimension. Okay. So pressure formula is, this formula is force, cite it properly. Pressure formula is force per unit area and then volume by time. Okay, let's put the dimension now. So pressure, force dimension is M1, L1, T to the power minus T. See, force is coming again and again. You better memorize it. Area area is length into breadth, so L square. Volume is length into breadth into height, that means L cube, length cube, so length cube will be L cube, and then time is there, so time will be given as it is. Next, yes, okay, it will go up. Let's arrange it. The up one, down one, T let's remain as it is. So M1 L means 1 plus 3, then this minus 2, then T to the power minus 2. Okay, so what will be this? M1 1 plus 3, 4, 4 minus 2 means L2, T to the power minus 2. This T, if it will go up, okay, so then it will be minus 1. So it will be what? Okay, so M1 L2 and T to the power minus 3. This is the dimension of universal gas constants. Okay. Okay. Next we will do it for electric field. Okay, this electric field also, the formula you will get it in your 10th standards, or 10 not 10, sorry, in 12th. Okay, electric current and magnetisms. So, but we will find out dimension now only. Okay, electric field. Electric field. So, what is the formula of electric field? Is force per unit charge. Okay, see, force is coming again and again, so it's better you remember it. Otherwise, you will. Otherwise, while solving problems, it will take times. And in JEE there is, in NEET there is limited times, so you better remember it, the force. Okay, so force is M1 L1 T to the power. I remember it, so I can write it. Okay, I can substitute. Charge is Q is equal to IT means ampere into time. I can write this also. Okay, because I remember it. Charge Q. Okay, Q is equal to I into T. I is current and T is time. Okay, so current is ampere and T is time. So now I can arrange it. M will remain as it is, L will remain as it is, T minus 2, and then this will also go minus 1, so minus 3, and then ampere will also have minus 1. So this is electric field. Okay, next, number 5, electric flux. So electric flux formula is electric field into area. Its formula is electric field into area. So electric field, just now we got, so electric field, directly we can substitute this one, M1 L1 T to the power minus 3 A to the power minus 1. The area means length square. So what will come? M1 L3 T to the power minus 3 A to the power minus 1. That's it, right? Yeah, but there is still some importance formula. So electric flux we have done. Next, what is remaining? Okay, Young modulus. Okay, let's see. Okay, there is Young modulus, Planck constant. So first we'll do for Planck constant. Okay, Planck constant. Easy. Planck constant's formula is E equal to h nu. E is the energy, h is Planck constant. Okay, Mr. Planck. Nu is frequency. Right. So now we have to find the dimension of this h. So we will make it alone on the RHS. Okay, or LHS. So h is equal to E by nu. Now we know that there is relations between frequency and time period. Okay, so frequency is equal to 1 by time period. This we have learned it in our class 9. Okay, this is the waves and oscillations. So but if you have not learned it, you learn it now. Okay, so frequency is equal to inverse of 1 by time periods. Okay, so E means energy. Okay, nu means 1 by T. So T will go up, it will be E into T. Now it's very easy. Okay, energy also I remember, so I can directly do like this: M1 L2 T to the power minus 2 and then T. Okay, energy, so it will be M1 L2 T to the power minus 2. This here is 1, so minus 2 plus 1 will be minus 1. So this is the dimension of the Planck constant. Okay, next we'll do it for next we will do it for what is it even, Young's modulus. Okay, before that that one we did, right? What is that? Universal gas constants. Okay, so universal gas constants, and one person's name is there, the Boltzmann. Okay, Boltzmann constants. So both have the same dimension. Okay, both have the same dimensions. Okay, you note it down there. So universal gas constants, and you give slice and you write Boltzmann constant also. They have the same dimensions. Okay, and both are very important because both of them comes again and again. Okay, so you write it, note it down there. Next we have number 6. Planck constants we have done. Okay, what did I told? What we'll do? A Young modulus. Okay, Young Babu, Young modulus. So Young modulus formula is Y is equal to stress by strain. Okay, I told you to do it first only. You practice, after that only you come. What is the formula of stress? Stress is force per unit area. Okay, and this strain. Okay, if you remember, strain formula is change in length. Okay, so change in length by original length. So this strain is dimensionless. Okay, strain is dimensionless. So dimensionless means we will not write because it's one only. So we directly find out for force per unit area. Okay, force per unit area. So force is coming again. Strain is dimensionless. Okay, stress is dimensionless. We have done it already. Okay, stress is dimensionless. So now force per unit area. Force is coming again, L1 T to the power minus 2. Area means length square. So what will be this? L will go up. Okay, you can do it easily, this one. M1 L1 plus 2, 1 minus 2 minus 1 T to the power minus 2. Okay, that's it. Okay, now last one is left. We'll do this and then we'll proceed to the JEE questions. Okay. Okay, next we have for specific gate capacity. Specific gate capacity, Q is equal to MS del T. Okay, so now what is this? Q stands for, it stands for heat. Okay, sir, heat we didn't got. Heat you got already. Heat is form of energy. So energy will have the same dimension as heat. Okay, M mass. Okay, S means this one. Okay, SHC, specific heat capacity. Del means one small rise. Okay, small changes. Okay, del means small changes. This del. Okay, this is called del, and it's represent small changes. Okay, small change. So here small change in temperature. Okay, so it is a temperature. Okay, this is a temperature. So now let's see. So heat is there. It is a formula. So we have to find out for S. So S we have to make it on one side only. So S is equal to M will come down, del T will come down. Q by M del T. Okay. So now we can substitute. So Q is heat, only heat is energy. So energy I remember already, so I can place it. So if you remember it, then you can also place it. Okay, after lots of practice, it will come automatically in your mind. Mass. Okay, so mass is calculated in, and then del T. Del T is temperature, and temperatures we have for Kelvin. Okay, arrange it now. Nothing means 1. So mm will get cancelled out. 1 minus 1, right? L to the power 2, t to the power minus 2, t to the power minus 1, given as it is. Okay, this one is 1. So m0, L2, t to the power minus 2, and k to the power minus 1. This is the dimension of specific heat capacity. And it's also very important. Okay, it comes again and again. So all this 6 I gave, it is very important. Okay, now you have to do it again and again, and this one is not enough. Whenever you get any new formula, at times just it will take 1 minute to find out the dimensions. Okay, so you practice it once and then you check it in the notebooks. Okay, otherwise you can search in the Googles. Okay, so whenever you find any new formula, you find out their dimensions. Okay, so now we will do one questions, okay, that comes in JEE Advanced 2023, and then similar questions came in 2024 also. Okay, so we will first solve the questions that came in JEE Advanced 2023. Now it is getting interest. You may be asking, but without doing this, you will not be able to do that one. Okay, first you practice this one. 2 times you practice it. After that, you come to these questions. Okay. Okay, this one is Young modulus. Let it remain here because it's going to be useful. Okay. Okay, let's grab it. Okay, let's see what that questions is. Okay. JEE 2023 advanced. Okay. Let's see what that question is. Question is Young modulus Y is expressed in derived quantity such as gravitational constant G, okay, Planck constant H, and speed of light c. Okay, if y is equal to c alpha, h beta, and g gamma. Okay, if y is equal to c alpha, h beta, g gamma, then alpha, beta, gamma can be written as, alpha, beta, gamma can be written as number option A, it was 7 minus 1 minus 2, number B 7 minus 1 2, number C was 7, okay, 1 minus 2, and number D it was minus 7 minus 1 minus 2. Okay, so which of the following is correct? Okay, so now solutions, let's see what is there. So now already questions is saying the Young modulus Y is expressed in derived quantities such as conventional constant G, Planck constant H spiral. Now this, if Y is equal to this one, then alpha, okay, we have to find the value of alpha, beta, and gamma. Okay, so how you will do? Okay, you will write it like this: Y is equal to C alpha, H beta, G gamma. Okay, so this one, now you remember, okay, Again, suppose in maths we have learned this one. If ax, okay, by is there, and then a p, and then b q is there. When these types of equations you show, then what you can do, you can equate their power, right? So you can write x is equal to p, and then y is equal to q. You can write or not? Yes, we can write it. So here also we are going to do the similar things. We'll find the dimensions of this, okay, and then some power dimensions will have some powers. Here also we'll find the dimensions, and then we will equate it. Okay, let's see how we will do. So Young modulus, first we should find its dimensions. So what is the dimensions of Young modulus? I will find it here. So y is equal to stress by strain. Okay, is it visible? Yeah, we have done it already. So if it is not visible, you do it yourself. Okay, so strain is dimensionless. So stress is force per unit area. So it will have m1 L1 t to the power minus 2. This area is length into breadth, so L square L minus 2. Okay, it will go up, means it will be L minus 2. So now m1 L to the power 1 minus 2 is minus 1 t to the power minus 2. So I will place it here. Okay, so it will be looking somehow like this. So y L1 L minus 1 t to the power minus 2. Whenever you see powers, then you know that we have to find the dimensions, right? Next we have c. C means velocity of light. Okay, so speed of light, speed is distance by time, so it's a velocity of light only, so it will be L t to the power minus 1. Okay, so if you remember, you can directly proceed. H, Planck constants. Okay, so Planck constants we will find it out. Okay, now what is Planck constants formula? Just now we did in importance. E equal to h mu, h equal to e into t will come. E is m1 L2 t to the power minus 2, and then t is letter t, so it will be m1 L2 and then t to the power minus 1. Okay, so you can substitute here m1 L2 and m1 L2 t to the power minus 1, right? Yes, m1 L2 t to the power minus 1 beta. Now we have the gamma. Okay, G. Let's find out what does G, what is the dimension of G. After finding this, we can easily equate the powers, and then we can find the value of alpha, beta, and gamma. Okay, so G, F is equal to G m1 into m2 by r square. So G is equal to f r square by m square. So F is equal to m1 and then L1 t to the power minus 2. R means L square. This will be m square. So what will be this? M to the power minus 1 L to the power 3, and then t to the power minus 2. Okay, so m minus 1 L to the power 3 t to the power minus 2. This is the gamma. This alpha, beta, and gammas are the alphabets of the Greek. Okay, Greek alphabets. You will learn it slowly. Alpha, beta, gamma. Okay. So now let's arrange it this one. Okay, let's arrange it M first. So M, first one is there, what? Beta. Okay, 1 into beta is 1 beta, and beta, M and then minus gamma. Okay, N is over, right? Only 2 N is there, 1. Next we will find it for L. Okay, so alpha, LL, yes, plus 2 beta, yes, Next, L 3 gamma. Okay, finished. Now T we will find out. T will be, yeah, some of you have done it. Very good. Okay, those who have not done, you can see it here. So T to the power minus alpha, and then T to the power minus beta, and then T to the power minus 2 gamma. Okay. So just now that time I did that, we can equate the power. So we will equate the power. Okay. So that means M1 we will compare it. So beta minus gamma will be equal to 1. Okay. Or we can write it like this. So beta is equal to 1 plus gamma. This equation 1. L. Okay. So L we will compare it now. L. Okay. So L will be alpha plus 2 beta plus 3 gamma equal to minus 1. This equation 2. I hope you can find it now. Alpha minus beta minus 2 gamma equal to minus 2. If we brought minus 2 this side and alpha will minus this side, then all will be positive, right? So alpha plus beta plus 2 gamma is equal to 2. This equation 3. Now we have to find the value of alpha, beta and gamma. Okay. So let's wrap it these questions and let there be all the options. Okay. You note the questions and then try to find it out by yourself. So what will be this? So beta is equal to 1 plus gamma. So beta is equal to 1 plus gamma. So this one is 1. So 1 in 2 we will put. Okay, 1 in 2. So 1 we will put in 2. So what will get? Alpha plus 2 into beta is there. Beta is 1 plus gamma plus 3 gamma equal to minus 1. So it will be alpha plus 2 gamma plus 3 gamma equal to minus 1. So it will be what? Alpha 2 will go means, it will go means minus 3, and 2 plus 3 is 5, and 5 when we will go this side it will be minus 5 gamma. This will give equation 4. Okay. After this, what we will do? 1 and 4. When we will put 1 and 4 here, then we will get the value of gamma, right? Yes. Alpha also value, beta also value is there. Then we will get the gamma. So we will put it in equation 3. 1 and 4 in 3. Okay. So alpha. So alpha value is minus 3 minus 5 gamma plus beta. Beta value is 1 plus gamma. Okay, 1 plus gamma plus 2 gamma is equal to 2. So what we will get? So minus 3 will minus 5 gamma plus 3 gamma. So it will be 2. Minus 3 will go means plus 3, and plus 1 it will go this side means it will be minus 1. So minus 5 plus 3 gamma it will be minus 2 gamma. 2 plus 3 5 minus 1 it will be 4. So it will be gamma is equal to minus 4 by 2 is equal to 2. So gamma is equal to minus 2. Okay. So gamma is equal to minus 2. So minus 2 here is there. This also minus 2. This also minus 2. This also minus 2. So 3 options are there. So we have to find out the other value also. Okay. So let's substitute this. Okay. 5. So gamma we will substitute in here 1. Okay. Next. Okay. Substituting gamma is equal here 1 will be what? What will you change one equations? equations 1 will be beta is equal to 1 plus gamma. Gamma means what? Minus 2. So it will be 1 minus 2 will be 1. So beta is equal to minus 1. Right? So beta is equal to minus 1. Okay. So minus 1 is also here, is also here. Here is also there. Now you have to find the alpha value also. Okay. So how you will find alpha value? Okay. Let's substitute it here. Okay, in equation 2. So equation 2, what will be it? Minus alpha. Alpha just now we got. Okay, alpha we have not got. Alpha plus 2 beta. Alpha plus 2 beta, right? 2 into beta. Beta value how much we got? Beta value how much we got? Beta value minus 1 we got. Right? And then plus 3 gamma. Plus 3 gamma value what we got? Minus 2. And the side how many is there? Minus 1. Okay. So what will be this? Acha. It's becoming so dirty. But okay, sir. Right? So it will be alpha minus 2 minus 5. Okay, minus 2 minus 6 is equal to how many is there? Minus 1. Okay. So alpha minus 8 is equal to minus 1. So alpha is equal to minus 1 plus 8. So alpha is equal to 7. So this means this is the correct answer. Okay. So congratulations. You have solved the first. You have solved the JEE advanced questions. Okay. This is JEE 2023. And JEE advanced also similar questions came. Okay. So let's see what is this. I just explain. You will solve it by yourself. Okay. So the questions was like this. Okay. You can copy it down after pausing. You copy it down. So let's see what type of questions was that one. Similar questions, okay. In 2024 it came. Now 2025 advanced is not held till now. Okay. I'm making video this on March. So till March 2025 advanced is not held. So the questions JEE advanced 24. Okay. So questions was like this. Okay. A dimension less quantity is constructed. Okay, dimensionless quantity is constructed using gravitational, okay, using electric charge E permittivity free space denote Planck constant h and velocity of light c. If dimension quantity is written as, if dimension is quantity is written as E alpha, E naught, beta, H, gamma and C delta. N is any natural number. Then okay, alpha, beta, gamma and 2, okay, and delta can be written as, okay. So the option was like this: minus plus n by n. Number A, number B, it was minus twice n by minus n n. Number C, it was minus twice n minus n, and then number D, minus twice n and then minus n. Okay, so how you will do this one? Okay, so a dimensionless quantity is constructed. Okay, if dimensionless quantity is written as, okay, if dimensionless quantity, okay, so how you will do this one? See, already hint is given in the questions. Dimensionless quantity is written as like this. So dimensionless quantity is written what? It is written like this: E alpha, E naught, beta, H, gamma, and C delta. So dimensionless quantity is written like this, right? So dimensionless quantity means what? Whose dimension is 0, M0, L0, T0, and here charge is also here. That means current will come. Okay, ampere will come. So ampere 0. So this dimensionless quantity will end. Now find out their dimensions. Okay, after finding out their dimensions, you can, what you can do, you can equate. Okay, you can equate the power. After that you will find the value alpha, beta, gamma, and delta. You find it, and then n is any natural number. Okay, in terms of beta you find it out. You find it out in terms of beta, or okay, alpha is equal to something, it will come. So options will come. So you solve it and you, okay, comment the answers. So for today this much. Thank you all of you. In the next class we will discuss about the uses. Okay, we will discuss about the homogeneity, and then some of the important rules that we should remember while doing the dimensions. That one we will do. So for now, study and then work hard. Thank you.